In the last video we dealt with sets, we dealt with certain features of sets and their forms, but today we'll be looking at a relationship between sets, that is how sets are related. Now let us look at a real life example. Looking at two different people, you see that they have one or two ways in which they are related to each other. Let's just take age as an example. You see that if you just pick just two people at random, you discover that there's always a relationship between their age. Is either one is older than the other, or the other is older than this, their age mates, or they are equal in age. So that's it. Now let's look at set A. Set A is defined as the first three natural numbers, and set B is defined as all natural numbers between 0 and 10, and set C is defined as all odd numbers between 1 and 10. So we have them in a tabular form. We say A is a subset of B if A is contained in B, that is all elements in A is in B. That is when A is a subset of B. That's the condition for subsets description. Now let's look at proper sets. Proper set and subsets, they are just like, they are just inverted. So if we say this is my elder brother, definitely I am his younger brother. This is my elder brother, definitely I am his elder. That is just how subset and proper set works. So if we say A is a subset of B, then B is a proper set of. A proper set is that set that contains at least one set more than the set we are describing. A. Let's look at superset. Superset is equivalent to proper set, provided that B is greater, in list and in element. That is, we can bring out A from B. Now let's look into universal set. Universal set is just described as the modern set of a number of sets. Now let's assume children of the same mother. Children of the same mother, they are the sets, that is, they are siblings to each other, they are all the same, like they tend to be on the same level, but their mother, which all of them come out from, is the universal set. So we have an example here. We define X as the set of all real numbers up to 50, and we also define Y as the set of all integers up to 50, and Z is defined as the set of all natural number up to 50. So we have X contain every negative whole number. That is, since we cannot just write them down, so we write minus infinity, then up to 0, then real numbers, their constituents are rational numbers and irrational numbers. So in between of 0, 1, 2, 3, we have a number of rational and irrational numbers. But for Y, it only contain the negative whole numbers, 0 and positive whole numbers. It is defined as every whole number, every positive whole number, excluding 0 is not a whole number. 0 is just so that's it. So that is universal set of a thing. So now if you are to describe the complement of a particular set, complement of a set is that set that encloses or that houses elements that are in the universal set but are absent in the set. So if actually for the complement of Y, every element that is not in Y but is present in the universal set is said to be the constituent of the complement of Y.